good morning, good afternoon, or good evening, depending on what time you're watching this video. So hopefully up to this point, you guys know how to do the double distribution of polynomials or the FOIL or whatever, the Punnett square, whatever method is easiest for you to use. So today I want to talk about some special products of polynomials and their patterns that you're going to use so that you don't have to do the FOIL method. The very first one we're going to do is looking at a perfect square where we have a plus b squared. So the way that we do this is you're always going to square the first number and you're going to square the last number, and your middle term is going to be 2 times the a term times the b term. Okay? For example, let's look at x plus 5 squared. So I'm going to square my first term, which is x squared. 5 times x is 5x, times 2 is going to give me 10x, and then 5 squared is 25. And so there is the special products. Let's do one more of these examples. So let's do example number 2. Let's go x plus 7 squared. Well, we're going to square the first number, which is going to be x squared. 7 times x is 7x, times 2 is 14x, and then 7 squared is 49. Okay? So that is going to be your first special product. Our second special product is going to be, we're going to look at a minus b squared. Again, this is exactly the same pattern as the one we just did above. You're going to square the first one. This time you're going to subtract 2 times ab plus b squared. Okay? So let's look at this one. Here's our first example. Let's go x minus 3 squared. We're going to square the first number. 3 times x is 3x, times 2 is going to give us 6x, and then negative 3 squared is going to give us 9. Okay, let's do one more of these examples. So let's try something a little harder this time. Let's put a coefficient with our variable. So 2x squared is going to give us 4x squared. 3 times 2 is 6x, times 2 is going to give us negative 12x, and 3 squared is going to give us 9. Okay? Now, the very last special products that we're going to talk about is the sum difference product pattern, okay? Sum and difference pattern. And in my opinion, this one's kind of easy. So let's get right into this. So this is going to be a plus b times a minus b, okay? And so with this one, you will always end up with a squared minus b squared, and you'll have no center terms because of these two signs or opposites. They're going to eliminate that center term when you combine them. Let's look at a problem like this. Here's our first example, okay? So I'm going to go x plus 5 times x minus 5, and that's going to give me x squared minus 25. Okay? Let's do one more of these. So example number 2. How about, let's go 3x plus 2 times 3x minus 2. Well, 3x times 3x is going to give me 9x squared. And then I'm going to have a negative 4. Okay? Everybody good? So I want to go and talk about a problem that I ran into the other day, and I want to finish our lesson looking at this problem. And it's actually talking about border collies. And when you guys were in biology, you did Punnett squares about eye color and stuff like that. Well, we can turn this into a product of binomials, and we can use the pattern or we can use regular FOIL in order to do this. But so let's look at this problem. The color of dark patches of a border collie coat is determined by the combination of two genes. An offspring inherits one patch color gene from each parent, and each parent has two color genes, and the offspring has equal chances of inheriting either one. The gene B, with a capital letter B, is for the black patches on the dog, and the gene lowercase r is for red patches. And any gene combination with a large B results in a black patch. Suppose that each parent has the same gene combination of BR. Let us draw a Punnett square that shows the possible gene combination. Well, believe it or not, this is a binomial. And so what we're going to do is we are going to create a Punnett square with 4 boxes. Parent number 1 has the same gene, BR. Parent number 2 has BR as well. And if we fill in our Punnett square, we were going to get B squared, BR, BR, and then lowercase r squared. Okay? So let's create a polynomial using this Punnett square. But we're going to look at this real quick. And if we look at this, we have 4 squares, which means we have 1/4 of each chance. So we have a 25% chance here to get B squared. We have another 25% chance here, another 25 or another 1/4% chance here, quarter, and then we have another quarter here. So let's write a polynomial using this information. So we want to go 0.25 B squared plus a half BR plus lowercase r squared. Oops, I made a mistake. That's going to be a quarter of r squared. Okay, now we have a second question. So this is our polynomial. So we've done this right here. So our second part of this question says, what percentage of the gene combination will result in the offspring being born with black patches? Well, we know that anything that has a big B is going to be born with black patches. Well, we have 25% here and we have 50% here. So if we add those together, we have a 75% chance of getting black patches. I hope you have enjoyed this video. I've enjoyed giving it to you. Have a great day.